Page 253, Chapter 2 Review. Yes, I'll record for Acrofest people who are gone. So those who are here, remind me so I don't forget to record for Acrofest people who are gone. No, music is not gone. You're leaving after class. Yeah, you're not missing classes. For a music group is going out next Sabbath too, but it's Friday night and Sabbath. I don't know what music group, but it's not class. Okay. Yeah, you're not missing class. Number 2, 253, number 2. Find the distance between the points whose coordinates are given, 5, -4. This is how those chapters always start, right? It's like, oh, this is easy. I don't have to do this. -3, -8. And then you drop off. You know, it's like when you're going on the roller coaster. Oh, this isn't so bad as you get up to the top of the first hill. And then distance formula. Square root second x minus first x quantity squared plus second y minus first y quantity squared. So, -3 minus 5, that's a -8. I square a -8 and I get a 64. Plus -8 plus 4 is a -4, square a -4, and I get a 16. What's 64 and 16? 80. Square root of 80, we want to simplify. What perfect square goes into it? Biggest one you can think of. 16, good answer. Times what? 5. Square root of 16 times square root of 5. 16 times 5 is 80. And what's the square root of 16? 4 square roots of 5 is the answer we are looking for. There is the distance between those 2 points. We'll do every other one together as far as we can make it at least. Number 7. Graph each equation by plotting points. Y equals absolute x minus 2 and then a plus 1. Remember what shape we expect to get out of this thing? A V shape. Now, we're going to use some techniques that we learned later in the chapter. And you also learned back in Algebra 1 and Algebra 2. But this thing is a V shape. We'll get some points. But this thing is a V shape that its parent has the vertex right at the origin. What does -2 do to a graph when it's on the x like that? To the right. To the right 2. And what does this plus 1 do to it? Up 1. I probably need to move my microphone a little closer. So those watching remotely, you're going to want to turn your volume down all of a sudden. All right. So if I take that and I go right 2 and up 1, I know this V is going to have a vertex right there. Now I'm still going to get some points. We'll still plot a few points. So I'm going to take 3, 4, and 5. X of 3, 4, and 5. See what sort of results we get from that. So if I put a 3 in, absolute 3 minus 2, and then add 1, what's that? 1 plus 1 is 2. Put a 4 in, just going to do it mentally. 4 minus 2 is 2, absolute 2 is still 2, plus 1 is 3. 5 in, 5 minus 2 is 3, 3 plus 1 is 4, so I can plot those points. 3, 2, 4, 3, 5, 4. Maybe I'll even be good and plot some points on the other side. -1, 0, and 1. -1, 0, and 1. Though if you remember the V shape, it's symmetrical and you can just match it on the other side. -1 minus 2 is a -3. Absolute is +3, so it becomes a 4. 0 minus 2 is -2. Absolute is 2, plus 1 is 3. You have to remember to take the absolute, which turns it positive. 1 minus 2 is -1. Absolute is 1, plus 1 is 2. Plot points. Plot pointing method is exactly what it sounds like. Get a bunch of X's. get enough points until you can trace out what the shape is. 14. Determine the center and radius of the circle with the given equation. And 14 happens to start us out not in the standard form for a circle, but just a nice general equation. X squared plus y squared plus 10x plus 4y plus 20. And you recall, the standard form for a circle is x minus h quantity squared plus y minus k quantity squared equals r squared, where h and k are the center, whatever those numbers are. H and k are the center of the circle, and that number on the end is the radius squared of the circle. So we are going to have to complete the square in order to get these nice little binomials squared. So we'll rearrange it with my x terms, x squared plus 10x. I'm going to leave some room to complete the square. Plus y squared plus 4y. Going to leave some room to complete the square. Equals, I'm going to subtract my 20 to move it over to the other side. So right now, it's just rearranging, getting my x terms together, y terms together, move the constant, move that number over to the other side. Then how do I complete the square on these x's? What do I do with that 10? Divide by 2 and square it. So divide by 2 is 5, 5 squared is 25. So if I add 25 to the left side, the students all said add 25 to the right side. The y terms, if I complete the square on that 4, half of 4 is 2, 2 squared is 4. So if I add 4 to the left, the students all say we add 4 to the right. All right. Now, we created two perfect square trinomials that I should be able to write in their factored form as something squared. X plus 5. It's always half of that b term. Half of 10, positive 10 is a positive 5. X plus 5 squared is just the factored form of that. Plus y plus 2 quantity squared equals, do all your addition on the other side, and what do you get? 9. Now, we are in the standard form, and we should be able to answer their question, determine the center and the radius of the circle. Where is the center of the circle? -5, -2, because it's always the opposite of that, because the formula is minus the h, minus the k. The radius is what? 3, because that 9 is the radius squared. So I just take the square root of that number, and the radius is 3. Determine whether the equation defines y as a function of x. So 18, x plus y squared equals 4. To be a function, what does it mean if something is a function? Every x gives exactly one y. So we're going to solve for y and determine whether we think this is a function or not. So subtract x. Y squared equals a -x plus the 4 that's there. How do I get rid of the square? Plus or minus square root. -x plus 4. So when I choose x's and put them in, do I get one answer for y? No. I get a positive answer and I get a negative answer. This is not a function. If, when you looked at that equation, you determined that, yes, I'll just get one answer when I put any x value in, that is a function. But this one is not a function. 22, you may want to look back. We learned things like vertical line tests and horizontal line tests. You may want to look back at that. So don't forget to look at the chapter as well as what I've laid out here. 22. So, different question. If g of x is square root 64 minus x squared, find g of 3. What does that mean we're doing? Yeah, we're just substituting 3 in. Square root 64 minus a 3 squared. Let's see, that'd be 9. 64 minus 9 is what? 55? Square root of 55? Any perfect square that goes into it? Nope. G of negative 5. Same idea, just substitute a negative 5 in there. 64 minus, in parentheses, a negative 5 is being squared, which is a 25. What's 64 minus 25? 39. Square root of 39. Any perfect square? Nope. We're done. C, G of 8. Square root of 64 minus 8 squared. 8 squared is 64. We get the square root of 0, which equals 0. D, G of negative x. Now we're applying the same techniques. We're just going to replace the x with what we're substituting, which is a negative x. 64 minus parentheses, a negative x squared. What do you get when you square a negative x? You get x squared. I get the square root of 64 minus x squared. That's it. That's my answer. It's as far as I can go. Next, 2g of t. So 2g of t means we are taking 2 times the function when I substitute a t into the function. So 2 times the square root of 64 minus t squared. You're done. There's no math you can do with that to simplify it anymore. F, part F, g of 2t. This is different. What are we substituting now? We're substituting it for the other one.
64 minus t squared and double, isn't it just 64 minus t squared and t squared?
No, it's 2 times the square root. And I can't multiply a 2 times something inside a square root. Can't do anything with that. Now, if the 2 was inside the square root, and I was multiplied by 2, it'd be 128 minus 2t squared. But I can't do anything with this 2 because it's like this. 2 times the square root of 3. Can I simplify that anymore? No, I can't multiply the 2 times the 3. It's just 2 times the square root of 3. Now this one, we're substituting a 2t into the equation. Square root of 64 minus 2t is being squared. I can do a little bit with this. What can I do? Square the 2t, which gives us what? 4t squared. Square root of 64 minus 4t squared. Now, is there anything common I can factor out of those two terms? I could factor out a 4. Square root of 4 times, how many times is 4 going to 64? 16 minus t squared. Now, this is a product. And just like earlier, when we had the square root of 16, where did it go? The square root of 16 times the square root of 5, that was earlier. But square root of 16 times the square root of 5, I can take the square root of 16 and leave the square root of 5. Well, I have the square root of 4 times the square root of 16 minus t squared. And what's the square root of 4? 2 square roots 16 minus t squared. So that one we actually could simplify for a while. 26. Determine the domain of the function represented by the given equation. F of x square root 6 minus x. Domains are values that we can put into our equation, and there's really only 2 restrictions. We can't divide by 0, and we can't take the square root of negatives. So I know whatever is inside the square root must be greater than or equal to 0. So I know my domain, 6 minus x, must be greater than or equal to 0. So I'm just going to solve for the x. I'm going to subtract 6, negative x, greater than or equal to negative 6. I'm going to multiply by a negative. X is less than or equal to, multiplied by negative, change the direction. 6. There's my domain. Wonder how they wrote it. I could say it's the set of all x's such that x is less than or equal to 6. That is our set builder notation. Or, if I'm less than or equal to 6, I can go from negative infinity all the way up to 6 and stop right there. I'll take either form. If they don't say one way or another, I'll take either way. They happen to do it the first way. I'll take it either way. Unless they say set builder notation, then I need that. Or interval notation, then I need that. Otherwise, we can read them both ways. We're bilingual. I don't know what that makes us bilingual. 32. 32. Graph. F of x, 4 minus square root of x. Any ideas on how we are going to go about trying to graph this thing? Let's plot some points. Now I'm going to think about my domain a minute. What do I know? I have a square root here. What do I know about my domain? Can't be negative. So I know my x's have to be greater than or equal to 0. So that's going to give me a hint when I go to plot some points. I'm only going to choose x's that are 0 and bigger. 0, 2, 4, 9. Now why am I choosing 2, 4, 9? Oh, 2. I don't want 2. 1, 4, 9. Why am I choosing 1, 4, 9? They're perfect squares, and I take the square root of them. You don't have to. You get a decimal, and that's fine. All right, if I put a 0 there, well, that's just 4 minus 0, so that's 4. If I put a 1, square root of 1 is 1. 4 minus 1 is 3. If I put a 4, square root of 4 is 2. 4 minus 2 is 2. Put a 9, square root of 9 is 3. 4 minus 3 is 1. 0, 4. 1, 3. 4, 2. 9, 1. Now it starts at this 0, 4. So it doesn't go forever. It starts there because of our domain restriction. X's have to be greater than or equal to 0. And it heads off to the right. Some of you maybe remember Algebra 2 and the square root graph that built up just going to the right. That negative reflected it across the x-axis. So now it goes down. And that 4 translated it up 4, and it became this. Or we can just plot points. 40. Find the slope of the line between the points with the given coordinates. Oh, it's back to another one of those. We thought the whole chapter was going to be like this. 6, negative 3. Negative 4, negative 1. How do we get the slope? Y sub 2 minus y sub 1, negative 1 minus negative 3, x sub 2 minus x sub 1, negative 4 minus a 6. Let's see, subtracting negatives we add. Negative 1 plus 3 is 2. Negative 4 minus 6 more is a negative 10. Reduce that fraction to negative 1 over 5, negative 1/5. There's the slope of that. 43, graph. Oh, we started graphing lines. I forgot that in this chapter. 3x minus 4y equals 8. What do we want to do with this equation so that we can graph it hopefully fairly easily? Solve for y. Put it in slope, what's it called? Intercept form. Solve for y. So I'm going to subtract 3x. Negative 4y equals negative 3x plus the 8 that was already there. Divide everything by a negative 4. Y equals positive 3/4 x minus 2. Where do we start graphing? Where's our first point? Negative 2. The y-intercept is negative 2. We want to start there. So 0, negative 2. And then what do we do?
Go up 3.
Rise 3, run 4. Up 3, right 4. From that dot, up 1, 2, 3, over 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And we draw our nice line. Find the equation of a line that passes through the points with the given coordinates. So if we are given 2 coordinates, we first want to find what? The slope. So 48, negative 4, negative 6. And 8/15. So we will first find the slope. 15 minus a negative 6 divided by 8 minus a negative 4. So 15 plus 6 is 21. 8 plus 4 is 12. What number goes into both those to reduce it? 3 goes into 21 7 times. 3 goes into 12 4 times. We have our slope. Now what? We have a slope. Point slope form. I'm going to write it out. Why don't you do the same? Y minus y sub 1 equals m times x minus x sub 1. Point slope form. That is a convenient form when we know a point and when we know the slope. So we figured out the slope. What point do you want to use? First one, sure. Does not matter. So y minus a negative 6, I'm going to put what instead of minus a negative 6? Plus 6 equals our slope, 7/4 times x plus 4. Minus a negative 4, minus a negative is plus 4. Now when they want an equation of a line, unless they specifically say leave it in point slope form, we put it in slope-intercept, solve for the y. So I'm going to distribute my 7/4. Y plus 6, 7/4 x plus, when I go to multiply 7/4 times 4, those 4's cancel, and we just get a 7. So now all we have to do is subtract 6, and we will have it in our slope-intercept form. Y equals 7/4 x plus 1. The equation of our line that goes through those 2 points that they told us. Cincuenta-dos. Is that right?
Yes.
52. Close enough. 52. Find the slope-intercept form of the equation of a line that passes through the points with coordinates 2, 6. So I'm going to write that down. Goes through 2, 6. And is perpendicular to the graph of 2x minus 5y equals 10. So what's this deal with perpendicular?
The slope's going to be negative reciprocal.
Slopes are going to be negative reciprocals. So I need to figure out the slope of this perpendicular line. And we'll just rearrange it to slope-intercept form to do it. Subtract the 2x. Negative 5y equals negative 2x plus the 10. Divide by negative 5. And all I really care about is that slope number. What is the slope of this line? 2 over 5, 2/5. So that means my perpendicular line has a slope of negative 5 over 2. And now we're just going to drop it into that point slope form. Y minus our y value, 6, equals our slope, negative 5 over 2, times x minus our x value of 2. We're going to distribute. How nice they were on these. They don't even leave fractions when we're done. Y minus 6 equals negative 5 over 2x. Negative 5 over 2 times negative 2 is just a positive 5. The 2's cancel. Add 6. Y equals negative 5 over 2x plus 11. There's the graph of a line that goes through the point 2, 6 and is perpendicular to that other one, 2x minus 5y equals 10. 56. Use the method of completing the square to write each a quadratic equation in its standard form. I'll start a new piece of paper. 56. Is that right, or did I? Yeah, 56. I'm going to write that standard form for a parabola. Y equals a parentheses x minus h quantity squared plus k. And the nice thing about this, Algebra 2 we called it Vertex Form because it tells us the vertex, h, k. And we complete the square because just like on the circle, we need another one of these binomial squared. So we want to get it into that form. 56, f of x, 2x squared plus 4x plus 5. Plus 5 minus 5 plus 5. I want to take the x's and work on completing the square on the x's. We can't complete the square if there's a coefficient other than 1 on that squared term. So we need to factor out the 2, leaving us x squared plus, how many x's if I factor out a 2? 2x. Leave space in there to complete the square, and then we can tack on the plus 5 onto the end. So in order to complete the square, we have to have a 1x squared. Now we can complete the square on this little trinomial here, the x squared plus 2x. So what do we do with that 2? Divide it by 2, which is 1, and square it. Square 1, we get a 1. Now the value of that 1, because of this 2 in front that's being multiplied, is really what value? A positive 2. And if I added 2 to the right, on the same right side, I then would need to subtract 2 to keep it even. Add 2 and subtract 2. Hasn't changed the value. But we have changed what the form looks like. And now we have it. 2 parentheses. What is being squared? This trinomial, if we factored it. X plus 1. Half of that 2 is 1. Quantity squared. And 5 minus 2 is a positive 3. There's our standard form. Did they want us to do something with it? No. That's all they wanted. What is the vertex of this? I'll answer your question here. Vertex is at -1, positive 3. If we were having to graph this, the vertex is -1, positive 3. It's opposite the h. Same thing as the k. Where did that -2 on the far right side come from? When we completed the square with that 1, that in value added 2, because 2 times 1 is 2. So I have to keep it equal by then subtracting 2. Add 2, subtract 2. So I have done 0 to it. 66. Find the requested value. The minimum value, g of x, 2x squared plus 3x minus 4. . If we graph that, what is the shape? It's a parabola. This parabola opens which direction? Up. Where are we going to find the minimum value of this parabola? At the vertex. How do we figure out the vertex? That's what we're looking for. We could put it in the standard form. Now, I'm not going to take that technique for this reason. When I look at my x's, I would have to factor out a 2, and when I factor out a 2 from that 3, I get fractions. So I'm going to use the formula. We can find the x value of the vertex by using negative b divided by 2a. So it is true that there are a couple of ways that you can get these answers. So negative b is a negative 3 divided by 2 times a, which is 2. So negative 3/4 is the x value of the vertex. Now that just tells me where I am in the x direction. That just says at, if I'm at negative 3/4, there would be my origin. That just tells me the x value is negative 3/4. The minimum value is the y value. That's what I'm trying to find. How do I get it? Substitute it back into the equation. 2 times negative 3/4 squared plus 3 times negative 3/4 minus 4 more. So we're going to exercise our brains, not our calculators, right? It's good practice for you. If you square a fraction, you know all you have to do is square each number. So this would be 9 over 16. Multiply things together, you just go numerator times numerator. So 3 times negative 3 is a negative 9 over a 4. And then there's that minus 4 on the end. Now, I'm going to get common denominators real quick. 2 goes into that 16 8 times. So I want a common denominator of 8. So if that 4 goes to 8, that 9 goes to 18. And if this 4 over 1 goes to 8, 8 times 4 is a 32. That goes to a negative 32. So I know I have something over 8. 9 eighths minus 18 eighths. What's 9 minus 18? Negative 9 eighths minus 32. What's negative 9 minus 32? Negative 9 minus 32 is how much? What? Negative 41. You actually will want nice fractional answers there. I just got a common denominator, and remember with common denominators, I know 8 is my denominator, that's going to be on the bottom. And I just take the numbers on the top. So we had 9 minus 18, which is a negative 9 minus 32 more. You just add 9 and 32, and the answer is negative 41 eighths. That's the minimum value. 68. Right there in the middle of that dash. Freight company has determined that its cost in dollars per delivery of X parcels, C of X 1050 plus 0.5X. Now what this is telling us is this $1,050 is a fixed cost, plus it costs $0.5 for every parcel. That's what that equation is telling us. The price it charges to send a parcel is $13 per parcel. Freight company determines that it's cost. Okay, that it's cost. This is what it charges. That's what it costs to send. They'll charge more. That's $13 a parcel. A, determine the revenue function. Revenue is the money that you get in. How do they get in money? $13 times every parcel they send. So in their description, we know, oh, the revenue function is 13x. That's how much money they get in. They charge $13 a parcel. We're done with part A. the profit function, B. Without the fancy equations, profit comes from doing what? How do we get it? Revenue minus cost. So it's just going to be the revenue function minus the cost function. So now I'm going to do my fancy equations. The revenue function was 13x minus the cost function, and I need parentheses because I have to subtract the whole cost function. 1,050 minus 0.5x, which we'll want to simplify, plus, thank you, which we'll want to simplify, 13x, distribute the negative, minus 1,050 minus 0.5x. We'll want to get our like terms together. 13 minus a half is 12.5x minus 1,050. So there is the revenue, how much money they actually make, depending on the number of parcels that they're sending out. What's that? Thank you. That is the profit they actually make, depending on how many parcels they send out. Yes. C, the minimum number of parcels the company must ship to break even. Break even means what in terms of revenue and cost? Equal. It's where they equal each other. Break even, don't make any profit. Which also means, what could I do with the profit equation to figure out how many parcels? Where does it equal 0? So that's what the technique I'm going to take. You could also use the technique of setting those setting the revenue and cost equal to each other. 12.5x minus 1,050 equals 0. We break even when we have no profit. Let's see, add 1,050, 12.5x equals 1,050, divide by 12.5. How many parcels? How many?
84.
84 parcels. Hey, that's not so bad. That's just one UPS truck. 72. Determine whether the graph of each equation is symmetric with respect to the x-axis, the y-axis, the origin. Okay, so here comes some stuff we're going to have to be memorizing. Let me get the equation written down first. What is it? Y equals x squared minus 7. If I want to check whether I am symmetrical with the x-axis, I'm a real visual person, so graphs are really, really helpful to me. If I have an example of something that is symmetrical to the x-axis, the same thing is happening above and below the x-axis. So if I have some point x comma y, I also have the point x comma negative y, and that tells me what to do. I just need to replace the y with a negative y, simplify it, and see if it makes the same original equation. That will tell me whether I'm symmetrical with the x-axis, which I hope is what they asked first. Yes. So I'm going to replace the y with a negative y equals x squared minus 7. I'm going to multiply by a negative so I can get it in the y equals form. Negative x squared plus 7. Does this match the original? No. This equation is not symmetrical with the x-axis. B. If I think of something that is symmetrical with the y-axis, like that shape. And again, if I have the point x comma y, what would be its matching symmetrical pair on the other side? Negative x comma y. I just need to go the opposite direction in the x. So I'm going to replace the x with a negative x. Y equals parentheses. My negative x needs to be squared and then subtract 7. What do you get when you square a negative x? You get a positive x squared. X squared minus 7. Does this match the original? Yes. This is symmetrical. In fact, if you thought of the graph of x squared minus 7, what is that graph? That's a parabola that's just been slid down 7. It's exactly like that red picture I have up there, except it's been slid down 7. It's symmetrical with the y-axis. Now, we are going to do the check for the origin. But can you tell me the answer now that you've thought about what the graph looks like? Is this symmetrical with the origin? No. I can't rotate it 180 degrees and it looks like itself. But symmetrical with the origin, the original xy, if you rotate it 180 degrees, you get negative x, negative y, comma, negative y. You replace both the x and the y with the negative versions. So I'm going to replace the y with a negative y, the x with a negative x, simplify it. Now I'm going to leave the negative y for a minute so that I can simplify the negative x squared to an x squared minus 7, and then multiply by a negative x squared plus 7. Does it look like the original? No, it does not. That is the check for an equation and symmetry with the x-axis, y-axis, origin. So I don't know if you need to make a little smiley face to remind yourself. I need to remember how to do those checks. 77. Same question, isn't it? xy equals 8. So if I do the x-axis, what do I do? Do you remember now?
Negative y.
Negative y. X comma negative y equals 8. Now if I multiply that together, I get a negative xy equals 8. Yes or no?
No.
No, that's not the original. B, y-axis symmetry. What do we do? Negative x. Negative x times ay equals 8. Multiply, negative xy equals 8. Is that the original? No. It is not symmetrical with the x-axis. It's not symmetrical with the y-axis. How do I check the origin? Both negative. Negative x times a negative y equals 8. What do you get when you multiply a negative x and a negative y? A positive xy equals 8. Is that the original? Yes, it is symmetrical with the origin. This graph, if you wanted to know what that graph looked like, that is what that graph looks like. It's symmetrical with the origin. It's not symmetrical with the x or the y-axis. So all this knowledge you're sticking into your head, the more you remember, the easier it is to answer it. Because if you knew what the graph looks like, I can give you an answer to the problem, and so could you. If you knew what the graph looked like. It's like, oh, I know what that thing looks like. No, no, yes. But that's no fun then if you can answer it that fast. 84. Sketch the graph of G, find domain and range of G, state whether G is even, odd, or neither. All right, some more stuff. G of x equals x cubed minus x. Now this is not a shape that we necessarily know at all, so how do we graph it? We're going to plot points. Did we learn in this chapter, didn't we learn about x-intercept, y-intercept in this chapter? Does anybody remember? I'll look back real quick and see if we learned about those intercepts. Maybe we didn't. You have that to look forward to. You actually already know how to do it, but... What's that? Yeah. All right. We'll just plot points, because I was going to use some of those other techniques to help us getting the graph. Is that in section 1? I was thinking we did. What page is that? Or did you already lose your page?
No, I just found it in the review section. So it says an example 5 160.
160. Oh, wait. Okay, yeah, we did the x-axis and the y-axis. Okay, so I'm going to use those techniques to help us out. We are going to plot points, but I'm going to start by y-intercept. The y-intercept is where the x is 0, is where I cross the y-axis. So I'm just going to put a 0 where the x's are, and what do you get? You get 0. It crosses the y-axis at 0, which means I'm pretty suspicious it also crosses the x-axis at 0, 0, 2. But let's go through, how do I figure out x-intercepts? X-intercepts is where the y is 0, or the function equals 0. So it's where x cubed minus x equals 0. Now we can factor this. What's common? X is common. X squared minus 1 equals 0. Ah, that x squared minus 1 can be factored. How? Difference of squares. X plus 1, x minus 1. So what are all the values of x that would make this equal 0? 0, negative, and positive 1. Now it crosses the x-axis at 0, which we already have. It also crosses at positive 1 and negative 1. Probably made my dot at the origin too big. Reduce it in size a little bit. Now I want to get some other points, but I am going to use those intercepts to help guide me in what x's I'm going to choose. I need to know what happens to the left of this far x, so maybe I'm going to choose a negative 2, negative 3. Negative 2, negative 3. I probably need to know what happens between these dots. I bet it's not just a flat horizontal line. So I'm going to get something between the dots, a negative 1/2 and a positive 1/2. And then I'm going to choose a 2 and a 3, so I have something on the other side. So I'm kind of using those intercept, those points that are no on it, to try to give me some guidance of what x's I might choose. Now I'm substituting it into this thing. Negative 2 has to be cubed, and I subtract a negative 2. Negative 8 plus 2 would be 6. I put a negative 3. This is not going to work out real well for me, I bet, with my negative 3. Negative 3 cubed is a negative 27. Add 3, that's a negative 24. So that's probably off my graph just a little bit, but that actually gives me some information. Negative 1/2. Negative 1/2 cubed is a negative 1/8. Minus a negative, which is plus 1/2. Negative 1/8 plus 4/8 would be 3/8. Right? If I put a positive 1/2 in there, that'd be a positive 1/8 minus my half, so that'd be 1/8 minus 4/8. That's a negative 3/8. This thing is kind of getting some symmetrical answers. Negative 6. Thank you very much. The very first one, negative 2, negative 6. 2, going to try to do that in our heads. What's 2 cubed? 8 minus 2. There's my positive 6. 3 cubed is 27 minus 3 is 24. Notice we're getting kind of the same answers. It's a symmetrical thing. Negative 2, negative 6. That negative 3 is way off the bottom. Negative 1/2 up 3/8, 1/2 down 3/8, over 2 up 6. There we go. Something like that. That's what this thing looks like. I wonder what the question was. 84. We drew a picture. Sketch the graph. All right. Find the domain and range. Domain are values of x that we can put in the equation. Are there any restrictions on putting any sort of x in this equation?
Oh, no.
No restrictions. Remember our only restrictions, there's only two we know about. What are they? Divide by 0, square root of negatives. We can't do either of those. We don't have either of those things going on, so all real numbers, I'm going to write an interval because it's real easy, from negative infinity to positive infinity. Everything. How about the range, the answers? Looking at the graph can really help me with that. The y values are the answers. What sort of answers do I get? From negative infinity to positive infinity. It's going down on the left forever. It's going up on the right forever. All reals again. I'm going to write it interval notation. Negative infinity to positive infinity. We can do everything. Domain range. State whether it is even, odd, or neither. Let's take some notes to remind ourselves. An even function has y-axis symmetry. It's symmetrical across the y-axis. An odd function is origin symmetry. It's symmetrical with the origin. Anything else is neither. It's not even or odd. It's not one of those two. Can you tell by looking at the graph, is that symmetrical with the y-axis? No. If I flip it across the y-axis, I don't have a matching thing across the y-axis. It is not an even function. Odd function, if I rotate that 180 degrees, does it look exactly like itself again? Yes, it does. This is an odd function. Now there is an algebra way to check this that I want to review for you because they may ask you to just check this. So let's continue our notes on this one. F of negative x, if I substitute a negative x and it just equals the original equation, that is an even function. If I substitute a negative x in, and when I simplify it, it looks exactly like the original, that's an even function. If I substitute a negative x, so we do the same thing, and it equals the opposite, or the negative of the original function, that is an odd function, and this one should work out. So we're going to do that. We're going to substitute a negative x into our equation, which was what? X cubed minus x? X cubed minus x. So x cubed, a negative x gets cubed, minus x minus a negative x. We're substituting a negative x into the equation. What do you get when you cube a negative? You get a negative. So that's really just a negative x cubed. Now minus a negative means I am adding. Now remember the original? The original function was x cubed minus x. Have we created something that is exactly the negative of the original? Yes. The original was a positive x cubed, we have a negative x cubed. It had a minus x, we have a plus x. It is odd. It is an odd function. However you do an arrow. Is that 84? 84. 87. Use the graph of the function below. Picture time. Use the graph, the function below, to sketch a graph of g. And they say on 87 that g of x is supposed to be our original function, but it's x plus 3. F of x plus 3. Because of the location of the plus 3, what has it done? Left 3. So if we do a sketch, looks like the original v is about 1, 1, the original origin. So if it originally was at about 1, 1 over here, I just need to go left 3. 1, 2, 3. Now I am back over here. All that's happened is I moved left 3. Well, that should be more symmetrical. My two sides aren't exactly the same. 90. Same original graph, they are just saying now our g of x is f of negative x. Okay, do you remember the effect when I put a negative onto the x? It's a reflection across the y-axis. I'm going to call it a y-axis reflection. You may have to sketch the original to be able to visualize what's going on this one. So my original was something like that. Is that right? Yeah. So if I do a y-axis reflection, I'm going to do it in red. Well, across the y-axis, my new vertex is just on the other side. I'm going to pick this point right here. That point gets flipped the same distance on the other side, so it's right here. This point gets flipped the same distance on the other side. It's right there. So in red is my new one. Y-axis reflection. Or reflected across the y-axis. 92. Use the graph of f below, so they're making it more challenging to sketch the graph of g of x equals 2 times f of x. What does this 2 do? Because of where it's located. It's a vertical stretch by 2. It's going to be twice as tall. So if we look at that original one on 92, it's going up to 2 and down to -2. So 1, 2, 3, 4. I now go all the way down to 4, all the way up to +4. And then what do we have? A flat piece. So there's our new one. The only difference is it's twice as tall, which means it goes up and down twice as much. (96). F of x be x squared plus x minus 2. G of x, 3x plus 1. Find each of the following. Part A, f plus g of 2. F plus g means our functions are added together, and then I'm going to substitute a 2. I'm going to take that approach. I'm just going to add the functions together. X squared plus x minus 2 plus 3x minus 1. I'm not going to add like terms. X squared, we have x plus 3x, that's plus 4x. What's that? Oh, that's plus 1. Thank you. Negative 2 plus 1 is a minus 1. So I just want to substitute a 2 into that thing. 2 squared plus 4 times 2 minus 1. I'll let you finish writing and then do some mental math and tell me the answer. 11. 4 plus 8 is 12, minus 1 is 11. Part B, f divided by g of negative 1. So our f function, x squared plus x minus 2, is being divided by our g function, 3x plus 1. Can't really do anything to simplify that, so we can just substitute a negative 1 into it. Let's see, 1 minus 1 is 0, minus 2 is a negative 2 in the numerator. Negative 3 plus 1 is a negative 2 in the denominator. 1 when we're all done. C, f minus g of x. Is that a sigh of satisfaction? Well, at least on this one, what are we substituting into it? Just an x, so it's just going to be the equations. We're done when we figured out the equations. So the f function is x squared plus x minus 2 minus the g function. So I need parentheses. We have to subtract the whole thing, 3x plus 1. All right, need to distribute x squared plus x minus 2. Distribute my negative, negative 3x minus 1. Collect like terms. And once we have collected our like terms, we're done. Because they say put an x in, what we did. X squared minus 2x minus 3. D, f times g of x. So again, it'll just be the equation where x is x. We just have to multiply them. X squared plus x minus 2 times 3x plus 1. How do we multiply polynomials? Very carefully. We do. What do? We distribute. Now I can go left to right or right to left. I'm going to go left to right. I'm going to take this 3x just because I have to only remember one thing at a time twice instead of one thing at a time 3 times. Though truthfully, it's the exact same number of multiplications. There's not really a faster way. 3x, I multiply it by all 3 of these. 3x cubed plus 3x squared minus 6x. I took the 3x and I distributed it. And then I take the 1 and distribute. And the nice thing about multiplying by 1 is I just copy it all, because it doesn't change. Plus x squared plus x minus 2. And I combine like terms. Since they didn't ask us to substitute any other value, there's our answer. What was that? 6? So we're on 99. Ah, ball rolling on a ramp. The distance traveled by a ball rolling down a ramp is given by s of t equals 3t squared. So here's the function that tells us how far the ball has rolled after t seconds, 3t squared. T is the time in seconds. S of t happens to be measured in feet. Evaluate the average velocity of the ball for each of the following time intervals. Now this is our difference quotient, it is called, where I go f of, I want to write it this way, then I need to translate it, minus. Okay, and my problem is I'm thinking of the calculus, because we write it this way when we start learning it. All right, we need S of t plus delta t minus S of t divided by delta t. Is that how they wrote it? When you're studying, and you don't remember, oh, they used A. They didn't use T, they used A there. A plus delta T. That's an A. The math is easier than writing out that equation we are doing. If my time interval, part A, is 2 to 4 seconds, our A is 2, that's the starting point. And our delta t is how much time is there between 2 and 4 seconds. 2. Delta means change in for math or science when we do it. So I need to use my function S of t, but I substitute A plus delta t into this equation, into that t spot. So 3 times something squared. Well, if A is 2, we start at 2, and our change in time is 2, what's 2 plus 2? 4. We're substituting a 4. Minus S of A, 3 times the original is 2 squared. All divided by delta t, my difference in time there is 2. 4 squared, that's 16 times 3 is 48. So what's 2 squared? 4. 3 times 4 is 12. What's 48 minus 12? 36. Divided by 2? 18 feet per second. That's our answer to part A. That's the average speed there. Now I'm going to jump down because we could do this on and on and on and on. Let's go to the last. Well, you pick. Do you want me to do C or D? They both work. They all work the same. But do you want me to do C or D? Let's do D. Interval from 2 to 2.01. Interval from 2 seconds to 2.01 seconds. That means our starting value A is 2, and our time interval delta t is 0.01. So when I use my equation, 3 times t squared, it's going to start as 3 times, well, I start at 2, and I add 0.01, 2.01 squared, minus 3 times, I start at 2 squared. All divided by, my time interval is 0.01. Use a calculator and be careful to get your numerator answer before you divide by 0.01. Give me 2 decimal places.
14,544.06.
12.03 feet per second. If I kept reducing that time interval shorter and shorter and shorter, we would discover that the instantaneous velocity of that ball 2 seconds after it started is 12 feet per second. It's just getting closer and closer and closer to the number 12. 101 will be our next every other one. Boy, you know you've done math when you're on problem 101, don't you? F of x equals 2x squared plus 7. G of x, absolute x minus 1. And they're wanting us to practice our combinations. F of g of negative 5. I'm going to do it, there are two methods. I'm going to do it using the numerical evaluation method, which means I take the g function, g of negative 5, and put that into the f function. So it's written f of g of negative 5. So I need to do the g of negative 5 first. So I just stick a negative 5 into that g function. What is the absolute value of negative 5 minus 1? 6. And I take that 6 and put it into the f function. 2 times 6 squared plus 7. 6 squared is 36, times 2 is 72, plus 7 more. 79, all the students repeated together. B, g of f of negative 5. So this means we're taking the g function, substituting the f function into it. So if I start by substituting negative 5 into the f function, 2 times negative 5 squared plus 7. So negative 5 squared is 25, times 2 is 50, plus 7 is 57. So now we take that 57 and substitute it into the g. Absolute 57 minus 1 equals 56. C, f of g of x. So this time we have to actually do it with the equations, with the x there, and see what we get. So this means take the g function, substitute it into the f. So the g function is the absolute x minus 1 that gets stuck right into the f function, right where that x is. 2, parentheses, absolute, x minus 1. Close the absolutes, we're going to square that. And we're going to add 7 to that. Let's see how far they took this. All right. A long ways. If I have the absolute, what does that do to any answer if I take the absolute of it? Makes it positive. Now what happens when I square any answer? That will also make it positive. So I actually can rewrite this just with the parentheses, x minus 1 squared plus 7. Because it will give me the same answer. Absolute makes it positive, so does squaring it. So that's a step I can do in simplifying this. It gets rid of my absolute values. Now I need to square that x minus 1. Now I'm going to use the formula. It means x minus 1 times x minus 1. Square the first thing, x squared. Multiply them together times 2. Negative x times 2 is negative 2x. Square the last thing. Negative 1 squared is a positive 1. Distribute my 2 and put like terms together. 2x squared minus 4x plus 2 plus 7. 2x squared minus 4x plus 9. Or D, we get to do it the other way. G of f of x. We have to take the whole f function and substitute into the g function, which actually is a little easier. The whole f function just gets stuck where that x is. So it's absolute, 2x squared plus 7, and there's a minus 1. Well, that's absolute 2x squared plus 6. And we're done. Well, they even did one more thing. So let me ask you about that. Question again, if I take absolute, it just makes the answer what sign? Positive. Because I am squaring this x, whether I put a negative or a positive there, when I square it, it changes it to a positive or makes it a positive, right? So what it really means is I don't even need the absolute values. 2x squared plus 6. I probably wouldn't count you wrong if you left the absolute values, but those are the same answers. Absolute values are unnecessary there because it has to be a positive answer because I'm squaring the x. 103. I don't know. What is 103? I got it. Remember how to do that on? You have to use software to do that one. We're out of time. Make sure that if we pull you into GeoGebra, remember what you do? You just put in your table, do regression, and they even tell us here a quadratic regression. And you write it out, the quadratic regression. Let me answer some of the questions. The quadratic regression, it has ax squared plus bx plus c. This happens to be a positive number there, so what do I know about the graph of this parabola? Goes up. I know the graph of that thing is going up like this. Their question B is, on the basis of this model, will the can ever be empty? Let me put a little more in for you. Will the can ever be empty? No, that's as low as it gets. It never hits 0 down here. This can will never be empty. You would get a graph that looks like that. You would see, no, it never gets empty. Explain where there seems to be a contradiction between the model and reality, in that we know that the can will eventually run out of water. So water escaping a ruptured can, it says the time and how much height is left in the can, or how much height is showing in the can, I guess. So they say it never reaches 0. What are they saying? Water escaping, I guess I should read the very first part of it.
Oh, so it's like a hole in the can.
There's just a hole in the can. Water escaping ruptured can.
What do they mean by height?
Yeah, their height seems a little funny.
So like
The height must be the can that's
that's what
showing.
they're saying. What's wrong with it? Because after the time goes down, or as the time goes up. Oh.
Well, what they're saying, this is height 0. In other words, there's 0 height of the can showing. It's right at the top. And then there's now a little more of the height of the can showing, a little more of the height of the can showing, a little more of the height of the can. I guess that's what they're saying.
The height of the water, technically, because after more time.
Their answer doesn't even make sense.
That's not.
We're not answering part C. See, the water is leaking out down there. What they have said doesn't make sense to me. We're done with our review. What happens Wednesday?